we have already gone through a equation of a circle and equation of a line when they are intersecting, and what are the conditions. We have gone through that when a line intersects a circle at two different points, then discriminant is greater than 0. When it intersects only at one point, that is discriminant is equal to 0, and when it does not intersect a circle, it is having a no solutions. So now, just taking that in consideration, we are having a topic condition of tangency, tangent in terms of m. Now, to find the equation of a tangent to a circle, x square plus y square is equal to a square in terms of its gradient. Now, let equation of a circle is x square plus y square is equal to a square. Equation of a line is y is equal to mx plus c. Solving 1 and 2, x square plus mx plus c whole square is equal to a square, and on solving this we are getting 1 plus m square with x square plus 2 mcx plus c square minus a square is equal to 0. Now, equation of a line is tangent to equation of a circle. Now, this means what? This means when a line is tangent to a circle. Now, we are dealing with the equations, that's why I have written a word equation of line, that is number 2, is tangent to equation of a circle, that is number 1. Only when discriminant is equal to 0, or we can say b square minus 4ac is equal to 0. Now, from equation 3, four m square c square, putting b square, it is 2mc, 4m square c square minus 4 times 1 plus m square with c square minus a square is equal to 0. And on solving, what we are getting? We are getting c square is equal to a square in the bracket 1 plus m square, or c is equal to plus minus a square root for 1 plus m square. Now, substituting value of c in equation 2, that is equation of a line. So, what we are getting? We are getting y is equal to mx plus minus square root for, so plus minus a square root for 1 plus m square and this is also called this is required required condition of tangency, required